Good afternoon. My name is Madam Kadhambi. I'm going to take you through Form 1 Chemistry revision. This is Form 1. This is Form 1 Chemistry revision. So the first question that you're going to be asked in any other class is that what is the role of chemistry, or why do you study chemistry? The reason why we study chemistry is because it is a career subject. When you study chemistry, you're going to be able to get yourself a career either in nursing, you can be a doctor, you can be lab technician. You know, lab technicians, they just mix chemicals. Then the second one can be, you can make, chemistry helps us make medicine, helps us make soaps or detergents. This is a unit that you're going, a topic that you're going to study deeper in Form 3 on how to make soaps and detergent. Then also helps you making polythene papers. Polythene papers, also one of the reason why we are going to we will be able to make polythene papers by studying chemistry. Now in Form 4 you're going to learn more about monomers and polymers, where you're going to understand when you mix a monomer with another monomer, you're going to get you're going to get polymer. So this is a unit that you're going to learn more in Form 4. Is a topic by itself. Now this, you're going to understand how we make polythene papers. These are plastic bags that we carry around in our homes. So now when you see, these are like the basics that you're going to understand more of how we make polythene papers. When you mix one monomer with another monomer, you're going to get a polymer, or then an ethane with an ethane, then you can get a polyethane. So when you mix an ethane with another ethane, you get a this is a polymer, then you're going to get a polyethane when we say polythene papers. So that is one reason why when you study chemistry, you're going to get such information, and then when you're going to be employed in a factory, you'll be able to understand how chemicals get mixed and can come up with such a good product. Now the second question for this revision is below is a diagram of a Bunsen burner. A Bunsen burner. So I will draw a Bunsen burner. So I think I should, let me just write the whole question. Below is a diagram of question 2 is below is a diagram of Bunsen burner. Use it to answer the following questions below. Use it to answer the following questions below. So a Bunsen burner looks like this. This is the So this is a diagram of a Bunsen burner. So there is name the following parts. So there is part D, then there is part E, and then there is part F. Then there is part F. Then from this other side we have part A. Then we have part B. Part B, and then we have part B, and this other side we have part C. So you're required to name the parts. Name parts A, B. So the question. So part A is the chimney. Part B the collar. This is the chimney. Part B is the collar. Part C is the base. This is the flame. Then we have part E has the air hole. And then the last one is the gas pipe. This is the source of the gas that comes in here. Then it's flown up here to we get a flame. Then you can also be asked a question, what is a flame? It doesn't have to be named parts of the Bunsen burner. You can also be asked what is a flame. You say a flame is a mass of burning gases. So a flame is a mass of burning gases. Remember, you can also be asked about maybe another question, the different types of flames. So you state these two differences of these flames. So you can have, I think I'm done with this Bunsen burner. So, okay. So now we can have, you can be asked about two types of, name two types of flames, types of flames. The two types of flames, we have type number one. When you're told to give a difference, you can either use conjunctions, like you say luminous flame is yellow, while, so you can use a conjunction like while to differentiate between a luminous flame and a non-luminous flame, or you can use a diagram. In this case, I'm going to use a diagram. So we have luminous, luminous, and then there's another one, non-luminous, non-luminous flame. So difference between luminous and non-luminous flame. Now the first difference is that luminous flame let me just say it is yellow in color. Well, this is blue in color. Then the flame is large and wavy, while the flame for non-luminous flame is short and steady. Then it is used for lighting. This one is used for eating. So a good example that we can use when we are giving the differences is that a luminous flame is a flame coming from a candle, for example, and also non-luminous flame is a flame that comes from a cooking vessel, like a jiko. It comes from just the gas cylinders that we use at our homes. Then just to state other differences, luminous flame does not have a sound. So, and then the other one produces sound. The other one is the luminous flame is fairly hot. Maybe I can add that because it's this one is very hot. This is very hot. So just like we are saying, a candle cannot be hot than a gas cylinder or a jiko. So the difference is that. Now, to get additional marks, because you don't have to, if you want to get additional marks when you find such a question, do not say a luminous flame is yellow while non-luminous is not. You not get good marks, you just get 1 point. But when you differentiate them using a luminous flame is yellow while non-luminous flame is blue, you're going to get 2 points. Now, the way you answer questions is also important, so do not use those ones like do not to just contradict the other. Just use one is yellow and the other one is blue, has a difference. Now, you can also be asked to ask their uses. How is a luminous flame used and how is non-luminous flame used? That is what I've already mentioned, that you can say a luminous flame is used for heating, while the non-luminous is used for heating, while the luminous is used for lighting, the same as we said it's a candle and a cooking vessel. So the fourth question is also a diagram that I'm going to draw of a graph, a melting and a boiling curve. So this is the third question. The third question that we are going to use in Form 1 chemistry revision is the graph below shows, say, the graph below shows the heating curve of water. The heating, so in the word heating curve of water. So this curve this is the temperature. This is the temperature in degrees Celsius. And this is time in minutes. So the curve looks like this is the curve, and this is point A, point B, C, D, and E. So question number 1 is, but before I go to the question number 1, there is a difference between a heating and a cooling curve. A cooling curve will not look like this. The wave will not go up. A cooling curve will have its wave coming down like this. This is a cooling curve, and this is a heating curve. Maybe you're melting something, then your curve is going to look like this. When you're heating, your curve is going to look like this. Now, at what temperature does water boil? water. So the question A is, yes, at what point does the water boil? So you get back to your curve, and this is the boiling point of water. The water will boil at 100 degrees Celsius. So the water is going to boil at 100 degrees Celsius. Now, is this curve another question that you will likely get in your exam? Is this curve for pure or impure water? Impure or impure, or pure or impure water? Then you're told to explain. So how do you tell this is a pure or an impure? How do you tell this is a pure or an impure? So in order to understand if this curve is a pure or an impure curve, you will look at how the curve flows. Now you see at this end, there is an inclination. So this is an impure water curve, because at this curve there is an inclination, and it doesn't have this horizontal. If it's pure, the curve will go like this. Just when it started to boil, just went like this. An example is when you're boiling water to use for your ugali. The boiling point for your water will be minus 85 degrees Celsius. Now this is an example for when you're boiling ugali. Now if you're boiling ugali, you'll add more flour. That means in this your pure water, you're adding more solid to that water, meaning it will fasten. It will increase the boiling point. What impurities does to water or liquids is that they add or reduce their boiling or their melting point. So it's either melting or boiling point. Now it's either they're increasing or they're decreasing their boiling points. Now this is a chemistry Form 1 revision questions. So state 5 examples of question 5. State 5 examples of acids. State 5 examples of acids. One, we have nitric acid. Nitric acid. Let me push it a little. We have nitric acid. The chemical like this, and then we have ascorbic acid. H8 and 0,6. Then the third acid is citric acid. I'm sure you've interacted with this more and more. Citric acid 6. 80 and 07 is the chemical formula for citric acid. And then we have hydrochloric acid. Chemical formula is HCl. Then we have the fifth acid is acetic acid or vinegar, CH3C00H. Then we have sulfuric acid, then maybe the last one to add on that is oxalic or and then dihydrochloric acid. So these are examples of acids. Then we have some acids we've interacted them in our day-to-day lives, like the acetic acids of vinegar. Vinegar is used in foods, either to add their preservation. They are used to in preservations of food, and then sometimes to sterilize meat. So sometimes you find that when you use vinegar in a substance that has hydrochloric acid, you find that the hydrochloric acid is going to go aside. An example is when you want to know your milk is contaminated, or it is not pure milk from the cow. You will add vinegar, which is acetic acid, So when you add vinegar to your milk, and mostly you find that they put hydrochloric acid in because it's soluble. It's hard for you to tell that this milk is has been added some other liquids for it to go higher. So you find that when you add acetic acid, the protein is going to come at the side. Now, if in real life you notice that the tangling of such proteins in one side is a chemical reaction. Now, at this, when you find that we have milk that goes by the side, it is called a chunk of protein. But when you use it in chemistry, we call them cards, protein cards, protein cards. That is when acetic acid and hydrochloric acid interacts, for example, in milk. Now, if you have questions, you can post, you can ask more questions regarding these types of acids, and maybe you need more clarification, you can still ask from our Facebook, KUTV Kenya. Our Facebook page is KUTV Kenya. So you can ask questions from there, or even use our SMS line. So quickly, I'll go to the next question. So the next question is name, I think it's question number 6, name the components, 4 components of hair. Now, we all know that nitrogen takes a bigger space in the hair. So maybe I'll just state them, then later I can draw them to see their percentage. Then we have oxygen, we have dust. Dust is part of a component. This is dust. Then the fourth component is carbon dioxide. Then the fifth component, water vapor and inert gases. So these are four. In exam, it's handy for you to find you being asked for more than 4 questions. Now maybe I can draw a presentation, a diagrammatic presentation of the components of, it's supposed to be a circle. Let me make it a this. Then so the bigger percentage of air component is nitrogen, which goes for 78%. Then we have oxygen. Now we have oxygen, which has 20%. Then we have carbon dioxide. apologize for the technical itch. We are back. I was giving the components for the question in our Form 1 chemistry revision, and the question was name 4 components of air. We had nitrogen taking 78%, oxygen 20%, carbon dioxide 0.03%, inert gases which are mainly argon, taking 0.97%, water vapor takes, this is water vapor with 1%, and dust. So so you might find such a question in your exam. So this was just a diagrammatic representation, but just to state them, we have nitric acid, which is nitric acid. Then the second component is ascorbic acid. Then the citric acid. Then we have HCl, which is the hydrochloric. Sorry about that, I just mixed the other question that was previous, but now we are looking at the components of air, which by just stating we have nitrogen, we have oxygen, then we have carbon dioxide, we have inert gases, and then we have water vapor. The last component is dust. So these are components of the air. Then I'll go to the last question, which is write an equation between hydrochloric acid and the following metals. So question number 6 is write an equation for hydrochloric acid and the following metals. For hydrochloric and the following metals. So metal number 1 is zinc metal, sodium metal, zinc metal. Number 2 is sodium metal. Then the last metal is magnesium metal. So it's a chemical equation between zinc metal and hydrochloric acid, sodium metal and hydrochloric acid, and the magnesium metal with hydrochloric has acid, sorry. So this is hydrochloric acid plus hydrochloric acid plus hydrochloric acid. Always make sure you understand the question before rushing to answering it. Now I'm going to write the chemical formula between zinc and hydrochloric acid. So the chemical formula for zinc is Zn. Now you have to specify if it's a solid, if it's a gas, if zinc is a metal, meaning it's a solid, you write a solid. If it's a gas, if now we get oxygen from hydrochloric acid, you get a G in that oxygen, or if it's hydrogen, you get a G in that hydrogen to show that it is a gas. Then if it's aqueous solution, it's annotated as AQ. Now for this question, we are using zinc. So zinc, which is a solid, notated as S, plus HCl, which is an aqueous solution. An aqueous solution is annotated as AQ. Remember, I said this is a solid S, and then this one is AQ to form magnesium chloride, and so remember now, if it's an aqueous solution, it will still go to this side as an aqueous solution, plus water. Water is liquid. Just like we said, this is a solid, this is an aqueous solution, and this one is a liquid. Now, what do we name this? What we get when we mix zinc metal and hydrochloric acid? We are going to get zinc chloride and hydrogen. This is hydrogen gas, but not water. So this is a gas. So we are going to get zinc. So this is zinc chloride. So we're going to get zinc chloride plus hydrogen gas. So Zn and Cl2, which is an aqueous solution. Now for sodium metal, when we mix it with hydrochloric acid, we are going to get sodium chloride plus hydrogen gas. Now the chemical formula is for sodium is Na, which is a solid. Remember I told you you have to annonate if it's a solid, is an aqueous solution, is it a gas, is it a liquid. If it's water, now it comes liquid. If it's oxygen, you're going to get a gas. Now you have in chemistry you will have to specify the state of that solution. Now plus HCl, which is an aqueous solution, will form sodium chloride, an aqueous solution, plus hydrogen, which is a gas. So this is sodium chloride. When you mix sodium metal with hydrochloric acid, you're going to get sodium chloride plus hydrogen gas. So we call it sodium chloride plus hydrogen gas. The same way we did the first one, because we are just mixing with one aqueous solution, which is hydrochloric acid. So the same thing is going to apply in magnesium, only that actually there is no difference in naming. So the same thing is going to happen here. So the chemical formula for magnesium is so apart from saying sodium metal, because these others are whole metal, we can't, let me give you another example. We use it as magnesium oxide. So in most of the exams you're going to me that they're giving you just metals up to number 3, but now let us mix magnesium oxide with hydrochloric acid. Now in this we are going to get magnesium oxide plus HCl, which is an aqueous solution, to form magnesium chloride written as MgCl2, and maybe I can write it here. Magnesium oxide plus hydrochloric acid. So we get magnesium oxide plus hydrochloric we get magnesium chloride and water. So what's difference? The difference that you've noticed when we mix magnesium oxide with hydrochloric acid is that the head result for metals is hydrogen gas, but now the head result for magnesium oxide is water, because now there is oxygen. Now the chemical formula for our result when we mix magnesium oxide with hydrochloric acid is so that you're going to see the difference. Here we are getting water, but with all others we are getting gases, which is hydrogen gas from hydrochloric acid. Now magnesium plus HCl, which is an aqueous solution, we get magnesium chloride plus H2O, which is liquid. Now this is the first liquid we have interacted with. All those others were solids, aqueous solutions and gases, but this is the first liquid when we mix zinc, when we mix magnesium oxide with water. Now the equation with zinc metal and sodium metal is the end result. If you get magnesium, we get between zinc and sodium metal, we get zinc chloride and sodium chloride. Well, with magnesium oxide, which I decided to change because those other two were metals, the end result is going to be water and magnesium chloride. So I hope you enjoyed. Continue to interact with us more and ask more questions on our social media platforms, which are all at KUTV Kenya, and we are going to be ready to answer them. Yeah, thank you. That was chemistry Form 1 revision questions and the expected answers. Thank you so much.